Okay, so let's go through question 1. Solve for the following for x. Okay, so this is back to exponential rules. So when you're trying to solve it, you need to get the same base. And what I'm talking about with the base is that number. So I'm going to change so I'll do it over here. So I'm going to leave that there at the moment, and what I want to do is make 1 over 25 the same base. Now, if you remember, I could say it's like saying 25 to the power of -1, couldn't I? Or something like that. Now, we also know that you could change 25 to be 5 squared, yeah? So the other way we could say is really what we're saying is that it's the same as 5 to the power of -2. Yeah, if I wanted to make that positive, I'd put it down underneath the fraction bar and it becomes a positive 2. So now that you've said that those two, you've got the same base, so you can say these powers equal each other. So you therefore can say that 2x plus 3 equals -2. Okay, and then you have a normal equation. So I'm just going to solve normally. I'm moving the 3 over, it becomes negative. So I get 2x equals -5, and x equals -5 divided by 2. And there's my answer. Okay, so let's start question 2. We've got to remember the log laws. So if you remember back, if we've got a plus, means we can, or actually before I even go there, I'm going to change this to, when you have a 2 out there, it can become a power. So what I'm going to do, I'll rewrite this here, sorry. I'm going to write, so log, I'm still keeping that one there at the moment. I don't want that 2, so I'm going to change it. So the rule is, it could be x squared like that, yeah? The 2 comes over to here to become a power there. Minus log 2, 6 equals -1. All right, so the next thing I'm going to do is I'm just going to deal with these two, and when you add, it means you times these guys together. All right, so the log law, so I'm going to have log 2 equals, now what's 3x times x squared? Wouldn't that be 3x cubed? And then I've still got the minus, haven't used that yet, -1. Now, when you minus them, you actually divide. So we've got log 2 equals 3x cubed divided by 6 equals -1. Okay, so if I simplify that, I've got log 2 equals x cubed over 2. I just simplified that fraction there, equals -1. All right, so now what you got to remember is, remember we said if we have it written like that, it could also be represented like this, log a y equals x. So I'm going to take this format here, which is this one here, and make it look like that. So what's my a in my diagram? So in my equation, a is 2, isn't it? Yeah, so I'm going to say it's 2 to the power of x. Now, x is what it's equal to. So I'm going to say 2 to the power of -1, yeah, equals what's sitting there, which is x cubed over 2, all right? Okay, so, sorry, I've got a bit of room here. I'm just rubbing this out. So you understood where I got that from. And so now at the moment, I have 2 -1 equals x cubed over 2. I'm going to keep changing. I'm not going to have that. I'm going to make that is the same as saying a half equals x cubed over 2. And then I'm just going to keep solving like I normally do. So 2, if I move the 2 over, it would be a half times 2 equals x cubed, which ends up being 1 equals x cubed. The opposite to cubing is the cubic root. And what's the cubic root of 1? Is 1. So there's my answer. Okay, so with this one, consider the polynomial, which is a cubic there. x cubed minus x squared minus 2x plus 2, the equation px equals 0 has 3 real solutions. So what they're telling you there is that this cubic can be factorized. You know, that's what they're saying. So you're going to get the factors. Because remember, if we can't find factors, it means, yeah, we won't be able to. So anyway, it's going to help you so you can do that. It had something else here. I changed it to say use the remainder theorem because to be more like your exam. So the remainder theorem, do you remember when you put you subbed a number in to try? And we always said try an easy number. So I'm going to try p of 1. And remember, if that equals 0, you find. So p of 1 would be 1 cubed minus 1 squared minus 2 times 1 plus 2. Now, that equals 0, doesn't it? Yeah? So, if that equals 0, therefore, I know that, remember, x minus 1 is a factor. Do you remember that? It's the opposite to what's in the little bracket up there, the p of 1. Now, if you remember, so it said just use the remainder theorem to find one factor. So, I've found a factor now. Okay, and then down here, find all linear factors. So I'm going to do that up here. Yeah, so we're going to find all the linear factors. So if you remember, to find the other factors, we do the division. Do you remember that? Used division. So what we're going to have is x minus 1 into x cubed minus x squared minus 2x plus 2. All right, it's going to get a little bit yucky here, but anyway, we'll work it out. So we go x into x cubed goes how many times? X squared, isn't it? So remember what we're doing is we're going, x cubed divided by x, yeah? And then we multiply it out. So now that you've done that, you go x times x, which is x cubed, and then x squared times -1, which is negative(x squared). And if you do that, remember we then minus, so then I get 0. Now this becomes a plus, so I also get, I'm going to say plus 0. Yeah? So we've got nothing there, so we're going to bring this guy down, -2x, and what we're going to say is x into -2x, what does it go? Minus 2x. So all this, it was really, we'd have 0 there, there's nothing there. So then we go -2x, oh sorry, it's not 2x, what is it? 2, sorry. So minus 2, so then we've got, we're going to multiply them this way, so, but this guy. So that will be -2x, and I've dragged this down, plus 2, and then I've got -2 times -1 is plus 2. So if you minus these, you'll see that they cancel out and get 0. So now what I know is that when I factorize this polynomial, I've got that it's x minus 1 is one factor, and up here, x squared minus 2 is another factor. Now, we need to factorize this as well if we can, and we must know we can because they told me I have 3 real solutions. So, if you remember back to DOPS, difference of perfect squares, if I have a squared term minus another squared term, it always factorizes to a plus b, a minus b. So what I'm going to do is change the -2 to be, I'm going to say it's square root squared, yeah? Because that would be the same as getting 2. So really, my factors are x plus square root 2 and x minus square root 2. Because that equals 2. Yeah, that's a way of changing it to a squared term. All right, so they're my factors, and I've done that. I'm just going to quickly explain what I mean. So if I had x squared minus 49, wouldn't you say that's x squared minus, you do the square root of that and you say it's the same as saying 7 squared, don't you? And then you factorize that to say x plus 7, x minus 7. That's what I've done. I've done the square root of 2. But you don't really, it's not an exact answer, is it? So I leave it like that. That's what I've done. Okay, so now they're asking us to sketch the function. So what we originally had was a cubic function. If I have to sketch the cubic function, I need to get the x-intercepts. And so to get the x-intercepts, that would be, is when the function, or p of x, equals 0, which means it's all the factors, isn't it? So you had the factors being, you had, it was x minus 1 and x plus square root 2 and x minus square root 2. So the x-intercepts, are you happy for me to say I would let all of those factors equal 0? So the x-intercepts are when x equals 1, x equals negative square root 2, and x equals positive square root 2. All right? What's the, if you know the square root of 1 is 1, the square root of 2 will be bigger than 1, won't it? So when I'm going down to mark them, I'm just going to say that's 1, and that's, I'm being a bit ridiculous with, as long as I'm saying it's bigger than 1, yeah? Don't worry too much about your scale. Now, and then I had, and then I have negative square root 2, which would be a negative number, yeah? Now I'm going to go draw my graph, and what I'm going to say is, see, this is a positive cubic. So a positive cubic starts down here, remember? Starts under the line. So I'm going to go, it goes up, down, and around. Really bad. It's hard for me to do it on this iPad, but you're going to have a cubic shape, yeah? Like that. Sorry, but mine's very messy. But they want you to show all the axes intercepts. So I better go and write them as the coordinates. So I'm going to say this is negative square root 2 and 0. I'm going to say this is 1 and 0. And this is positive square root 2 and 0. And I'm also going to get the y-intercept. And I'm going to say that's 0, 2. How do I know that's 2? Because up here, yeah, when the y-intercepts, when x equals 0, if I pop that x equals 0, I get 2. So there you go, there's a cubic. It said not necessary to show the turning points. So as long as I have a cubic shape starting in the right area, cutting through those intercepts correct, you'll get all your marks. Okay? Try to draw a nicer graph than that, please. Okay, so in this next one, you've asked to find dy dx, the derivative. There is like 2 ways you could have gone about it. It is not hard for you guys to expand that out, the original, so that you could then just use normal derivative things. So if I expanded that out, I could technically, so what I'm saying is I multiply them out like that, just so I don't have those brackets. So then I would have had 3x squared plus x minus 6x minus 3. So I could say that is the original equation. So when I go to find dy dx, a lot easier. So 2 times 3 is 6x minus 5. So there's your answer. You might have done that. I am going to show you with the chain rule, okay, so that you can practice that. So if I had, this is with the chain rule. Okay, so with the chain rule, if I've got y equals, so I've come across here and say I'm going, yep, they look a bit nasty, I don't know how to expand that. So what I'm going to do is I'm going to call this u and this v. And remember, so if I call that u, x minus 2, if I say the derivative of u would be 1, and if I say v is 3x plus 1, the derivative of v would be 3. The chain rule is actually, so dy dx is equal to v du plus u dv, yeah? So I'm going to go that guy with that one and that one with that one. So what I have there is equal to 3 times, oh sorry, I'll do it what the rule says. So I've got 1 times 3x plus 1 plus 3 times the x minus 2. So I've matched those two up. If I expand that out, I've got 3x plus 1 plus 3x minus 6. Yeah? So then I have, which would give me 6x minus 5. And that's the same, isn't it? Yeah? Is that not the same answer? Same. Good. Okay, so let's do this next one. They're asking us, that's actually to find, that's to find the derivative, g of x there. Okay, so what I'm going to do is I'm going to change this to be written in a way I find it easier. So instead of having the square root of x, the square root of x is the same as saying x to the power of a half. And I'm going to say instead of having this x over 2 here, I'm going to say it's like saying 3x to the negative 2. Okay? That makes my life a lot easier to find the derivative because it is a half times 4 and then it would be you minus 1, don't you? Then it'd be minus 3 times negative 2 and x, and you'd minus 1 there, which becomes that. So I end up, if you go a half times 4, don't you get 2? Yeah? 2x to the negative a half plus, because a negative by a negative would give a positive 6x to the negative 3. What? So then, I don't like the negative powers, so I'm going to put that one down the bottom, which is x to the power of a half, and I'm going to have 6x to the power of 3. And I don't even like that little half. I might even change it back to 2 square root x plus 6 over square root 3. So I might say the derivative is that. But no point did it say positive powers or no surds, or you know what I mean? So you don't have to. Technically, I believe if you got to here, you should get the right answer. You should get the answer, yeah? But remember we said you just got to look for other things. They might push you further. In year 12, they might say then, make it positive powers, make it no surds, whatever. Okay? Okay, so with this one, if you don't remember, this is the symbol for antiderivative. It means you've got to go backwards, yeah? So antiderivative is, if I just fix that up, that's 3x power of 4 plus 2x minus pi, okay? Okay, so when you're finding antiderivative, you're actually going back to the function, so I might just say f of x equals. Now, you add a power and you divide by that new power, don't you? Yeah? So then, if I add a power to this x, it becomes squared, and I divide by that new power. And I would still have to do it to pi. So I'm adding x to the power of 1 and dividing it by 1. Now, this is antiderivative, so you always have to have plus c. There might have been a number there, you don't know. So I'm just going to tidy that up. So f of x would equal to, can't fix that anymore, so I'll leave that as a fraction. This one I can, 2 over 2, so that became x squared. I'm not going to have over 1. I'm going to leave it like that, and I'm going to have plus c, and that is the answer. Oh, sorry, that's the answer. Okay, this is another antiderivative one, but we have to, now they're going to push you a bit more and get you to find the c. First of all, I do not like this antiderivative with the fraction there. I don't like it. So most likely it's something I've not had to deal with when I'm just normally doing the antiderivative. So probably you don't have to deal with it either. So can you see, if I break this up like that, so I've sort of sectioned them, you could actually say that's the same as saying, isn't it x to the power of 3 minus 3x? Yeah? Okay, now I'm going to go find the antiderivative. So I'm going to go back to f of x. So I'm going to go x to the power of 4 and divide by that new power, minus 3 to the power of 2 and divide by that new power. Oh, sorry, this one's not x, is it? What is it? Just 3. Yeah? Sorry, take that one back. So it would be, if I raise it to a power, it comes to x to the power of 1 minus 1 plus c. Okay, so the function at the moment, tidy that one up, would be minus 3x plus c. Okay, we need c. The only way you can find c is if you use a point. They gave you a point here. They gave you the point that when x equals 2, y equals 3. So I can pop that in here. Everywhere I see x, I will put a 2, and where y was. So I work that out. 2 to the power of 4 is actually 16. 6 even. Okay, so we got 3 equals, that would be 4 minus 6 plus c. So 3 equals negative 2 plus c. So positive 5 equals c. So therefore the function is x over 4, power 4, minus 3x plus 5. Okay, so the next one is we're solving, this is a circular functions equation. So first, oh sorry, I wrote that wrong, didn't I? That was equals negative 1, and it's for when x is a element of between 0. That should have been pi. That p meant pi there as well. Okay, so let's go solve it. First you do your little rearrange, because I'm going to say cos 4x. I'm going to bring the square root over, is equal to 1 over square root 2. So back to remember our circular functions and remembering exact values. It's written in the way we don't normally remember. Do you remember if I do this and I rationalize, it'd be square root 2 on 2. So remember your little hand trick for cos, yeah? It's the square root you've put down. Whoa, this is bad. But anyway, do you know what I mean? Here's my little, fingers, yeah? So I put down the 45 one, yes? And it's the square root of the right over 2, yeah? So I would get 45. So I know that, because what we're going to do, why I did that was, we're going to, first of all, just let the 4x equal pi. So when does cos theta equal negative square root 2? So you've worked out that it's we've worked out positive 1 is square root over 2. So if we go back to our unit circle, okay, where is cos negative? It'd be over here, yeah? So isn't that cos is the x-axis, yeah? So it's negative over there. So what we've done is we've gone back 45 degrees, but we probably want to talk in radians. So what's 45 in radians? You can just do 45 over 180, which is 1/4. Yeah, so it's 1/4 pi. Yeah? Okay, so if I've gone, over here would be pi. If I've gone back 1/4, what am I on? 3 pi on 4? Yeah? Yes? Are you happy with that? Where else in the circle will that be negative? Down here, wouldn't it?
Yes.
and wouldn't that be pi plus pi on 4? So what would that be? 5 pi on 4? Yes?
Yeah.
So cos is going to be negative there. All right, well, negative 1 root 2. So I could write over here, cos theta equals negative 1 root 2 when theta equals, you said 3 pi on 4, yeah? 5 pi on 4. I'm just going to keep putting some more answers on, going around that circle. Why am I going to do that? Because I can see that it's 4 up there. So when I start timesing that by 4 down the bottom, it's going to be out of 16, isn't it? And that means I've got to go all the way up to 16 pi over 16. So I've got a few answers there, I reckon. So what I'm going to do, if you went all the way around the circle again, wouldn't you be at 3 pi? Yeah? If I did a whole another lap. I get there. So 3 pi would actually be 12 pi on 4. So if you're one quarter short of 12 of them, you would be at 11 pi on 4. Can you see that? So and then what would, if I'm 1 quarter above 12, I'd be 13 pi on 4. I'm just going to leave those ones there. So I know that, but the actual question was, when is cos 4x equal to negative 1 on 2? So remember, you take that 4 and you times it here, yeah? And if you have a look, so my answer would be when the angle is 3 pi on 16, 5 pi on 16, 11 pi on 16, and 13 pi on 16. Have I gone over a full pi there? Nah. 16 on 16 would be a pi, 1 pi, full pi, yeah? So I'm within the thing. So there's your answer there. All right, so here they're asking you to graph the function of this. So if you remember, this moves the basic graph up. So you can see that that is sitting on, it's moved up to 1. Now the 4 tells you the amp. So from 1 up to the top, what would that be? 1 plus 4 is 5. Now what's 1 minus 4 would be? Negative 3. So this guy is like that, yeah? So there's what the graph's going up and down to. This number in here is how you work out the period. So the period is always that number there divided by 2 pi, so which is actually 2 divided by, it's actually 2 pi divided by that number. Sorry. Yeah. So 2 pi divided by that number. So 2 pi divided by 2 equals pi. So it took it up to pi to get to do one cycle. So when you're asked for the domain, remember domain means the x values that it can be. So if you have a look, it goes from, it includes 0 because there's a solid dot there. You can see it more on your paper. And we go all the way up to pi, yeah? All right, so what's the domain of this? So because they're saying I see those solid dots, I'm going to say the domain is including 0 all the way up to pi and including pi, yeah? The range is all the y values. So can you see it's going from here to here, yeah? And that peaks at 5 and drops at negative 3. So the domain I'm going to say is, what's the smallest one? 3. And then the biggest one? 5. All right? Okay, so in question 8, they've said the gradient of a straight line is 2. So what I'm going to say is I know that the straight line is 2x. I know that for sure. Now, they said the straight line is a tangent. So this guy is a tangent to the curve, which has an equation of this: y equals x squared minus 4x plus 1. and it says find the equation of the line, of the straight line. So I'm going to just summarize that. That's find the equation of the tangent line. I already know the gradient, so I'm missing the c value, aren't I? Yeah? So I need this. Now to get that, I need a point. Yeah? Oh, sorry, I can't spell. Oh, can't even. Oh, God. All right, so I need a point. So an x and a y, like that. Okay, if this line is tangent to the curve, that means the derivative of the curve will equal the gradient of the tangent, yeah? Which we know is, what's the gradient of the tangent? Which is 2. So if I go and find dy dx, which is 2x minus 4, I know that that equals 2 at the point where this tangent and that cross. Alright, so I'm just going to finish this question. Oh, no. Alright, so you know that the gradient equals 2, so therefore you can find what x is at that point. So you've got 2 plus 4 equals 2x, so you've got 6 equals 2x, so 3 equals x. So at the point where this tangent is, x is equal to 3. So I then can use the equation of the curve at that point to get the y value, because remember we need an x and y. So I'm going to sub in 3 into the equation. So I end up with, what's that? That's 9 minus 12 plus 1. So y equals negative 2. So I now have this point over here. The point I have is 3 and negative 2. So into my tangent equation, 2x plus c, I'm going to put those values so that I can work out what c is. So I get negative 2 minus 6 equals c, so negative 8 equals c. So the equation of the tangent is 2x minus 8, and that's the answer. Okay, so with question 9, it says show that the stationary points of the graph there occur at the points where x equals and so on. So what you should be doing is when you look at these questions, start writing straight away. Stationary points means dy dx equals 0. Okay, so if I need to show that to the stationary points, I probably need to get dy dx. So if we go and do that, so dy dx of the function, so it'd be 4x cubed minus 15x squared minus 4x. Okay, so we know the stationary points are when this equals 0. So this is a cubic, and if I let that equal 0, how do we solve a cubic? We're going to let that equal 0. So to solve a cubic, you need to factorize it. So if you have a look there, they all have x in them. So if I take a common factor out, so we should always look for a common factor, we're left with 4x squared minus 15x minus 4. Now, so I factorized that. So now I don't even really need to I'm not factorizing a cubic. If I go to factorize in there, that's a quadratic. So what I'm going to do is I'm going to try the cross method. So I think of factors of 4x squared. So I'm going to try 4x and x. Alright, so I've got factors of the 4x squared. Now I'm going to think of factors of negative 4 on the other side. Because I want 15 in there, I've thought to myself that 4 times 4 is 16. So I'm going to use that. Now, if we're checking the cross method, so 4x times negative 4 would be negative 16x. And then x times positive 1 would be x. if I add them, do I get what's up here? Yes. So we now know that these are my factors. So if I'm going to just keep factorizing it over here. So my factors now of this thing are going to be 4x plus 1 and x minus 4. So this is all equaling 0. So then null factor law states we can let each factor equal 0. And there I have one answer. And then if I rearrange this, I get x equals negative a quarter. And if I rearrange this, I get x equals 4. So I now have the 4 answers that they asked me, and I've showed that. Okay? Okay, so then we're moving on. It says with the find the values of x for which the function given there has a positive gradient. So this is a quartic. We might not really know how to sketch that. That's going to get difficult. So we sort of need to think about it in calculus. Now, if you think about calculus, if you find dy dx, isn't that the formula for the gradient? Are you happy for that, for me to say that? So it's the formula for the gradient. So we've worked out in the question before, because this is still the same function, we worked out that formula, and you told me it was, actually it ended up being that cubic, didn't it? But if I write it in the factorized form, whatever, say like that, so it's a cubic, isn't it? Yeah? And you know the x-intercepts is x equals 0, x equals negative a quarter, and x equals 4. That's what they told us in the question before, didn't they? So what I'm going to do is, I'm going to graph the gradient. So I'm graphing the gradient, so which I know is a cubic. So if I do that, this is that gradient graphed. So I know I have an x-intercept of x equals 0. I have an x-intercept of negative a quarter and an x-intercept of 4. Okay? Now if I go graph this was a positive cubic. So it started up here, it goes like that, and goes something like that, wouldn't it? Yes? Okay. If you remember back in what we talked about, when you asked when is this gradient positive? When is this function, the gradient, positive? So I've sketched the graph of the gradient. So when is this y? When are the y values positive? So up here is when the gradient of the real function is positive, isn't it? Because I'm graphing the gradient, not that original function. And then down here would be when it's negative. So when do they ask me, when is it positive? Well, it's positive between here and here, isn't it? Before it goes under that line, and also out there, that bit. So how do you write that in using your maths or set notation? You say, all right, any number when x is between 0 and negative 4, yeah? And then I'm going to say in union with, or that means and also, when x is greater than 4, okay? So I graphed the derivative so that I could see when it was positive and when it was negative, because I couldn't graph a quartic, the original function. I had no idea what that was going to look like. That was out of my skill set. So can you see how we can do it that way? Yes? All right, good. Okay, so let's do this last question 10. So a cardboard box is in the shape of a square prism with side lengths x and a y centimeters as shown in the diagram. The sum of all the side lengths is 120. What they just told you there, that little blurb bit there, what that actually meant was the perimeter of all the sides, yeah, has to equal 120. Okay, so, and now they want me to show that the area in centimeters is given by this. So if you look there, they're only using x. So what I need to do is get this y in terms of x. So this perimeter piece of information is going to help me. So if you look up the perimeter, if we add all the side bits, so I've got x there, so there's an x, plus this x, and this x. So I'm just gonna be a little bit briefer and just say there's 4 x's there. And then there's another 4 down here, isn't there? Yes? So plus another 4 x's, all those sides. And then you've got this y, and you've got 1, 2, 3, 4. So I've got plus 4y. Now, I know that that's 120. They said when you add all those side bits up, it ends up being 120. So I am going to rearrange this so I get y in terms of x. So really what I've got here is 8x plus 4y. Okay, I could divide everything by 4 and get 30 equals 2x plus y. So I just divided everything by 4 then to simplify it. Okay, and then I'm going to keep rearranging. I'm going to say that 30 minus 2x equals y. So now I have y in terms of x. So if I go down here to show, it says show that the total surface area is this. So surface area is when you find the area of all the sides. So if you think of it, I have I've got this top piece and this bottom piece, and the area of those two, there'd be 2 of them, and they're actually x times x, which is x squared. And then I'm going to add all these 4 side bits. Sorry, it's hard to see, but there's 4 of those side panels. And so we're going to say plus 4 of the side panels, which are actually a square, which is x times y. But, so I've got 2x squared. I'm now going to, instead of having y, I'm going to put this, what y actually is. So it's actually x times 30 minus 2x. Okay, so let's keep on expanding that out and see what we get. So I'll just leave the 4 outside at the moment, and I'd have 30x minus 2x squared. Then I'll times out that 4, which would give me 120x minus 8x squared. Now I can group like terms here. So I'll do that. So I end up with negative 6x squared plus 120x. And is that what they asked me to find? Yeah. So we've shown that. Just flicking back. Centimeter. So find the maximum surface area of the box and the value of x when maximum occurs. So we have a formula for surface area. They said it was negative 6x squared plus 120x. So we sort of have a function. So they're asking us to find the maximum function, like the function's maximum. Now we know they occur at the turning points, don't they? Yeah? So, and if you have a look, this is a quadratic, a negative quadratic. So wouldn't it look something like this? Yeah? And so there's, because this would be surface area against x, and there's its maximum. So you've got to try and think of all this so it will help you. So you're going to say, right, the turning point of a negative quadratic is going to give us the maximum. And we know that the turning points happen when dy dx equals 0. So we might do dy dx. There could be another way. You could use the turning point formula. Remember negative b over 2a? You can do that if you wanted to, but let's just do the derivative. So the derivative of this function would be negative 12x plus 120, and then you're going to let that equal 0. Okay, so then you get negative 120 equals negative 12x, so you see that 10 equals x. So the maximum occurs, when x equals 10. Now they asked me to find the maximum surface area, so I need to go into the surface area formula and put 10, yeah? So it'd be negative 610 squared plus 120 times 10. So we're going to have negative 600 plus 1,200, so equals 600. So the maximum surface area was this in meters? Sorry? So centimeters squared. All right, justify that the surface area found in part B is a maximum, so 1 mark. What you can do is to justify that, you could say because x equals 10, let's just try, then y must equal, remember we wrote the formula, that's what y equaled with the amount of material or something they said, the sum of all the sides. So if you put 10 into here, it'd be 30 minus 2 times 10, so which is y equals 10 as well. So let's go test. If y equals 10 and x equals 10, and you knew the perimeter was 8x plus 4y, so 8 times 10 plus 4 times 10, does that give 120? Yeah, and that's what we said we had, so there you go. That one, just put anything to try and show that it matches. That one wasn't too important.